In this video, we're going to take a look at the first order differential equation that we've seen already a few times. I'm just going to remind you about how this particular differential equation is separable, and this gives us an analytic way of solving for the solution x of t. So this is our differential equation that we're going to consider. Keep in mind this is the same thing as if we had x dot minus ax is equal to 0. And remember, in this case, we're going to consider no external forcing. So this is the homogeneous equation. When this is separable, this allows us to bring all of the x's to one side. So we keep the dx term on the left and we divide by x. And then we keep all the non-x terms, in particular anything that's involving t, over to the right-hand side. And now we can just integrate both sides. And this integral, 1 over x, turns into the natural log, and this integral of the constant a just turns into at plus c. These are indefinite integrals, and so this constant allows us to capture both of the constants of integration. If we exponentiate both sides, like in this equation here, then the exponential and the natural log cancel, and so this leaves us just with x. And so now we're solving explicitly for x of t. And the right-hand side, you get e to the at plus c in the exponent. And this is equal to, with your rules of exponentiation, e to the at, and then times e to the c. And so we can just rename this as our multiplying factor, and we're going to call that x0 simply because that is in fact the initial condition for the state, because when t is equal to 0, that exponential is just 1, which leaves us to be x of 0 is equal to x0. And so this allows us to get a way of solving explicitly for the analytic solution of the first order differential equation in the homogeneous case. And so we're going to see a parallel of this when we study solving the state space equations, which are also first order. However, they are now the x is going to be vector valued. In this case, x is simply just a number, and with the state space first order equation that we'll take a look at in subsequent videos, that x will then become a vector.